Welcome to solverfy.
Okay, so we're doing chapter 23, problem 27 here. So it says we have a plus 25 microcoulomb point charge, and we have an identical one 6 centimeters away, which we call big D. And we want to say how much work would it be required by an external force to move a 0.18 microcoulombs charge 1 centimeter closer to either one. Doesn't really matter. So to do this, we need to figure out how the potential energies are, because from the work energy theorem, we know that the work is the delta change in energy. If all of our charges are stationary here, we don't have to think about kinetic energy, and this is just the change in potential. So that's the final potential minus the initial potential. So that's all we have to find now. So let's figure out what the initial potential is. So first, a potential for a point charge. Oh, okay, so the electric potential between 2 point charges is given as the multiplication or product of their charges over 4 pi epsilon naught times the distance between them. So initially, we're going to have two components of potential energy, which is the left point charge with the middle one and the middle one with the right one. So let's go ahead and add on that. So we know we have 1 over 4 pi epsilon naught. And now we have little q big Q over d over 2. And we add on the other one, which is exactly the same. Cool. So this becomes q over 4 pi epsilon naught d times 4. So these 4s will cancel out. Awesome. So now let's figure out what the final is. We have now the same charges, but we have a distance d plus d and another distance d minus d. Sorry, d over 2 plus d and d over 2 minus d. So we can add this up as 1 over 4 pi epsilon naught q, and then 1 over d over 2 minus d plus 1 over d over 2 plus d. Okay? So if we're now trying to find work, this is just the final minus the initial. So we're left with q over 4 pi epsilon naught. And then the final was 1 over d over 2 minus d plus 1 over d over 2 plus d plus 4 over d. If we plug all this in, we have the first charge, or big Q, being 25 microcoulombs times 0.18 microcoulombs all over 4 pi times epsilon naught all times, okay, so d over 2 is 3 centimeters, little d is 1 centimeters, so this becomes 2 centimeters. The other one is 4 centimeters, and the last one is 4 over 6 centimeters. Cool. Plug all that in. Don't forget to convert your microcoulombs to coulombs here. So this is times 10 to the negative 6. This is times 10 to the negative 6. And what we're left with when we put everything in our calculator is 0.34 joules. Awesome.